alpha minus beta, given that the sine of alpha is negative 4 over 5, and the cosine of beta is negative 5 over 8. For all, okay, so it says alpha is in the third quadrant, and beta is in the second quadrant. Okay, so remember that we have a formula for this, right? So if we're trying to get a cosine of an angle and we don't have those angles in the unit circle, we're going to use two that we do have in the unit circle. Okay, either add or subtract based on what you're trying to get, and then use a formula. So we know for cosine, it's cosine, cosine, sine, sine. Cosine, cosine, sine, sine. So it's cosine of the first, cosine of the second, then switch this sign, so instead of negative, it'll be positive. So I'll write it over here. So it'll be cosine of the first, cosine of the second. Change this minus into plus, then get the sine, sine of the first, sine of the second. Okay, but in order to do that, we need to set up right triangles based on what they gave us, right? Because we need to find the cosine instead of, we need to figure out these different values. Okay, now they told us that sine of alpha is negative 4 over 5 in the third quadrant. So basically over here, we have a right triangle, and we're gonna label it with the information given to us. Okay, so SOHCAHTOA, sine is opposite over hypotenuse. Okay, so opposite, it's gonna be negative 4. Hypotenuse will be 5. Right? And this makes sense because remember that in the third quadrant, sine is negative, right? So that means opposite makes sense to have a negative. Okay, so then now we're gonna have to find adjacent by doing the Pythagorean theorem. So this is gonna be one of the legs squared plus the other leg squared equals the hypotenuse squared. You probably already know that it's 3. But because of the 3, 4, 5 special triangle, but either way, let's do that. So it's gonna be 8 squared plus 16 equals 25. 8 squared equals 25 minus 16, which is 9. So A is 3. Okay, but then think about it. Does it make sense for it to be a positive 3 or a negative 3? It's gonna have to be a negative 3 because in the third quadrant, cosine is negative and sine is negative. So both of these are negative. Okay. In other words, section 5.3, we're using a point on this line that it is negative 3, comma negative 4. Okay, this is all alpha. Okay, on the other side, we need to draw beta. Beta is in the second quadrant. Okay, they gave us the cosine. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. So it makes sense for the 5 to be negative because we're in the second quadrant, so cosine is negative. Okay, and now again, do Pythagorean theorem. So it's going to be a squared leg squared plus the other leg squared equals the hypotenuse squared. Let's solve for, that looks like a 0, so instead of 0, let's put B. Right, we're gonna solve for the opposite. Let that opposite be represented by B. So this is negative 5 squared, which is 25. There's 8 squared, which is 64. So it's B squared equals 64 minus 25, which is, let's do math. Okay, hopefully I did that right. And then square root both sides. So B is the square root of 39. Okay. Okay, it takes some time, but it's not that hard. Just draw the right triangles in the correct quadrants, label it, find the missing side, and then based on that, we're going to be able to use the formula cosine, cosine, sine, sine. Okay. So just for space, I want to erase this work. And so now we get to actually just solve it out. So this is going to be cosine of alpha. Alpha is over here. So cosine is adjacent over hypotenuse. So adjacent is negative 3. The hypotenuse is 5 for the cosine of alpha. Okay. that guy. We have to also get the sine of alpha. Well, that's given to us, so that's just the negative 4 over 5, right? That's alpha. Now we need to get beta. So we need to get the cosine of beta that was given to us. And we're going to get the sine of beta. And remember what is sine? Opposite over hypotenuse. Opposite over hypotenuse. Okay? And then just do the math and see what you get. So here we're going to get 15 over 40. Remember when you multiply fractions, you just multiply it out, you don't need common denominators. And over here is going to be negative 4 times the square root of 39 over 40. Okay, since they both have a denominator of 40, we'll just write it all over 40. Okay, and that is your beautiful answer for example 3. Alright. Alright, example 4 is similar in the sense that you have two angles, and you're going to use either the cosine or sine sum and difference formulas, but we're still going to have two right triangles, and so we'll go ahead and we'll do it. Okay, so here we go. So we have sine of arctangent Okay, so we're trying to, this is example number 4, page 656 and 6.2. So we're gonna go ahead and we're gonna solve it out. But first, remember that we could just, remember that this is gonna return an angle. It's gonna return another angle. So you can let this first angle be represented by U and the second angle be represented by V. And then in that case, you would have sine of the summation of two angles, and we know that formula, right? This is sine, sine, cosine, cosine, and then of course keep the same sign in the middle. Okay, so this is good because all we have to do is label the triangles, figure it out. Okay, so here, okay, so we have arctangent of a negative. No, so this is going to give us, we've done this before, we've got an arctangent of a negative number, and we get something in the fourth quadrant, right? Because it has to be either in the first or the fourth, so it's going to be in the fourth. Okay, and this one, this is arc cosine of a positive number, and remember that's between 0 and pi. Alrighty, so that's going to be in the first quadrant. Okay, so then now let's go ahead and let's label. So we're gonna go ahead and let me use a different marker. So we're gonna let theta equal this guy just like we did in the last section. And then again, if you were to get the tangent of both sides, okay, then you get the tangent of theta equals the tangent of arctangent of negative 9 over 40. Okay, and then these cancel as long as this value is between, negative pi over 2 and negative pi over 2, which we've already said that this is in the fourth quadrant. So we're okay. So based on this, we're going to label this triangle. And tangent, we know tangent is opposite over adjacent. Opposite over adjacent. that means that all we have to do is find the hypotenuse. You guys know how to do the Pythagorean theorem. Once you do hypotenuse, you'll get 41. You can check it later. Okay, and on the other side, if we maybe I shouldn't call it theta, let's call it beta. Let's let beta equal this inside angle. Oh, well, since I let it be u and v, let's use u and v. So this is gonna be, so you can get the cosine of both sides, right? In order to cancel out the arc cosine. Okay, and these will cancel out as long as let me go back to my previous section, 5.7. This is all page 620. So cosine and arc cosine, when you put arc cosine in first, it's okay as long as x is between -1 and 1, which that is a fraction between -1 and 1. Again, by this point, many times you're just able to just do the inverse function and they'll cancel. Okay, it's not gonna be like trying to trick you type of thing. But anyway, so based on this, we're gonna go ahead and label this triangle. And so we know that this is going to be the opposite. This is adjacent. This is hypotenuse. And so it's going to be 8 over 17. So SOHCAHTOA. And again, I recommend going to the textbook because it is a lot of material. Okay, but it all goes back to, can you draw the right triangle in the right quadrant, use the Pythagorean theorem, use inverse functions, and then solve it out. So here, remember that cosine is adjacent over hypotenuse, so adjacent is going to be 8 and hypotenuse is going to be 17. And then again, this makes sense because in the first quadrant, we're going to have cosine positive. Okay, and just in case you're wondering why did we put this arc cosine 8 over 17 in the first quadrant, remember that we only have two options, the first or the second, because it's from 0 to pi. We've talked about that before, we've written it down in our notes. And so cosine over here is negative, so it's not going to be in the second quadrant, it has to be in the first. Now you guys do Pythagorean theorem and you guys solve it out, and then what do you get? I'm just going to write it for you because it would take too long for us to do again. So it's going to be 15, okay? And then based on that, you guys can go ahead and solve this out. So this is saying, can you get the sine of u? Okay, so u's over here, sine. Sine is opposite over hypotenuse, so it's going to be -9 over hypotenuse of 41. Sine of v, sine over here is opposite over hypotenuse, so it's 15 over 17. Then cosine of u is adjacent over hypotenuse for u over here, so adjacent is 40, hypotenuse is 41. And then cosine of v would be over here, adjacent over hypotenuse. And then just do the work. Thankfully, it's the same denominator. It's just 41 times 17, which is 697. And then just do the rest. So it's going to be -9 times 15, -135 plus 320. So it's going to be 185. Wait, let me see. -941 times 15 over 7. Sine. Oops, I apologize about that. So this formula is sine cosine, cosine, sine. That does not usually happen to me because I like these formulas, sine and cosine. So I'll probably give it to you guys to use. Sine, cosine, cosine, sine. So therefore I flip to these. Okay, so the answer should actually be, which at this point is just algebra. It should be 528 over 697. Is the answer to all, without using the calculator, using the information that we know. Okay, so this is written as the exact value, which is super cool because that is what you would get if you plugged it into the calculator, but of course we need to do it this way to verify that we know what we're doing. Okay, there's another question here that says to prove one of the formulas. We're not going to prove it. To use the cofunction identity, which all you got to do is just use the formula. So it's saying, is it really true that one of the cofunctions identity is correct? We'll go back to the sum and difference formulas. Remember that sine of two angles is sine, cosine, cosine, sine. Okay. Then there's another one to verify the identities, which we spent a lot of time in 6.1 verifying identities. Remember that all you gotta do is use what you know, right? So you can use the trig identities. For now that you know these formulas, you can use the sum and difference formulas. Alrighty. Alright, just because I think it is useful to make sure we know this formula correctly, it's telling us, can you prove one of the cofunctions identities? Okay, so we always usually start off with the left side. Okay, so this is prove this identity. Okay, so remember sine is sine, cosine, cosine, sine. Okay, and you use the same sign. Okay, sine, cosine, cosine, sine of, yeah, this is theta, of these two angles. Okay, perfect. Now let's figure out what we can. So what is sine of pi over 2? Pi over 2 is right over here. Sine is the y value, so that's just 1. So it's going to be 1 times cosine of theta minus, and then what's cosine of pi over 2? 0, so all this is going to go away. So we just proved it, cosine equals cosine. Okay, so again, use what you have. There is one identity that is super awesome, but I'm going to do it in class.